In this lesson, we will learn how to add vectors using component method. In our previous lessons, we discussed two methods of adding vectors graphically: tail-to-tip method and parallelogram method. In this lesson, we will discuss the component method of adding vectors and the advantages of using component method over graphical method. Consider two vectors, a bar and b bar. Let the vector a bar be of magnitude 4 units and directed at an angle of 30 degrees from the positive x-axis. Let the magnitude of the second vector b bar be 8 units and directed at an angle of 60 degrees to the positive x-axis. Let the resultant vector obtained by adding these two vectors be c bar. Therefore, c bar is equal to a bar plus b bar. We will now discuss the process of adding these two vectors using component method. Step 1. Represent the given vectors in their unit vector notation. Recalling the process of resolving a vector into its components. Given a vector of magnitude v and at an angle theta with positive x-axis, the x component of the vector is given by the vector vx bar is equal to v cos theta times I hat. Similarly, the y component of the vector is given by vy bar is equal to v sin theta times j hat. Therefore, a bar is equal to 4 cos 30 times I hat plus 4 sin 30 times j hat, which is equal to 2 root 3 times I hat plus 2 times j hat. Similarly, b bar is equal to 8 cos 60 times I hat plus 8 sin 60 times j hat, which is equal to 4 times I hat plus 4 root 3 times j hat. Step 2. Now to add the two vectors a bar and b bar, add the x components of both the vectors to obtain the x component of the resultant vector. Similarly, add the y and z components of the vectors to obtain the y and z components of the resultant vector. Do take sign into consideration while adding the components. Also do not add the x and y components. Here, x component of the vector a bar is equal to 2 root 3 times I hat, and x component of the vector b bar is equal to 4 times I hat. Therefore, the x component of the resultant vector c bar is equal to 2 root 3 times I hat plus 4 I hat, which is equal to 2 root 3 plus 4 times I hat. Similarly, y component of the vector a bar is equal to 2 times j hat, and y component of the vector b bar is equal to 4 root 3 times j hat. Therefore, y component of the resultant vector c bar is equal to 2 times j hat plus 4 root 3 times j hat, which is equal to 2 plus 4 root 3 times j hat. Therefore, the resultant vector c bar is given by c bar is equal to 2 root 3 plus 4 times I hat plus 2 plus 4 root 3 times j hat. Now if we compare graphical method of adding vectors with component method of adding vectors, we see that the component method has following advantages. Vectors need not be drawn to scale. Components of the vector can be used in place of the actual vector. Addition or subtraction can be done using the components itself. Recap of the concepts we discussed in this lesson. In this lesson, we have seen how to add vectors using component method. We also discussed the advantages of component method of adding vectors over graphical method.